Hello. I'm Big Kate, and I'm not good with mics. I'm your herald for this session. The plan was for a guy called Josh Lackey to speak, but apparently he's MIA, so he's not speaking. So we have Steve, and we have John, and we have their names. Sorry, David Hulton. I'm not up here, and I'll talk to you a bit about them. And that's one. Okay, fine. David here has extensive design experience and hacking experience. He's designed the BSD Air Tools, has done extensive research in wireless, smart card and GSM design, and more importantly has looking at high-speed crypto hacking FPGAs. He runs the Open Cipher program. Now, Steve here is a complete cipher to me. I have not a clue about him, and apparently he wants to keep it that way. The talk is about, okay, we have the talk, with lots of GSM support for GNU Radio. David and Steve here are here today to present a technical presentation on the current state of GSM security. The plane to cover is what it takes to get past open air encryption, monitoring unencrypted GSM, various attack mechanisms. They're planning to make some code presentations, and with the goal of making a feasible A5 cracker. What they would like to get out of this is some discussion about this, and to look for suggestions and feedback. And their plan is to talk for a while, and we'll then have a Q&A at the end. And I think that's me, done.
Thanks.
Testing. Whoa. Okay, so I'm David Holton. She already introduced me, and wow, it's very echoey in here. Yeah, and so this is Steve. Basically, what we're going to do is he's going to talk about the GSM scanner project for the first half of the talk, and then I'm going to show you how to break GSM after that. So, I guess, go ahead, Josh. Or, sorry, Steve.
All right, thanks a lot. So, as David said, this talk is split into two halves. I first explain you a little bit about GSM, about the security in GSM, and then David will tell you about how to crack A5, the encryption algorithm of GSM. And first off, well, let's get rid of this slide.
Next one?
Directly, yeah. Let me tell you about the GSM scanner project, or we renamed it to the GSM software project for legal reasons. If you have a software, it's legal. If you have a scanner, it's not. So first off, the GSM software project, we started in January 2006, so we only started this year. And there are a couple of reasons why we started this. Well, first reason, people said, you know, no one has ever done this before. Great. People said, it's probably very hard to do. Great. And then most important, they said, you'll probably piss off a lot of companies. Oh, great. We want to do that. That's really great. Yeah, so we decided, let's get our heads together and think about how can we receive GSM signals. And we have a couple of methods, and some of the methods I'll present today. And yeah, let's get started. Next slide, please. GSM. GSM stands for Groupe Spécial Mobile. This is French, and no one really knows why they named it that way, but that's how it is. And it's a digital mobile communication design or protocol. It was designed in the 80s and became live in 91, I think. It currently has 2 billion subscribers. That's 2 billion subscribers worldwide. So it's the largest mobile network ever. And, well, I forgot to mention, this is a public project. All what we do is published on our website. You can read about it, and you can participate in this project. You can join our mailing list. And there's a very important reason why this is a public project. And this is the first question you should ask me later, okay? So don't forget, later on ask me, Steve, why is this a public project? All right, let's get started. Let me tell you a little bit about the GSM network. This is a rough idea how a GSM network looks like. You have a mobile phone here, you have a base station, you have a lot of computers, base station concentrators, blah, 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 and then you have this, the AUC. This is the authentication database. This is where all your secret keys are stored in, okay? So in this talk, I will concentrate on this one and on this part. The rest is just hardware we don't care about. Let's get started. Okay. GSM uses base stations, and you probably have seen them sometimes when you look around and you see these antennas, and these base stations are combined into clusters, and each base station has a maximum reach of 35 kilometers. 35 kilometers. This is from here to Berlin, is that right, roughly? So if you're sitting here with the receiver and someone in Berlin is doing a phone call, yeah, you can receive him if you're lucky. Okay, that's how far it goes. Let's go to the next slide and I'll show you some pictures of what the base station looks like. This is how a typical base station looks like. You have usually 3 antennas, and each antenna is a directional antenna with a 120-degree angle. So you have a mast with 3 antennas, each of them pointing into one direction, covering all the way around. I'll show you another pictures. Sometimes you don't see the base stations. There's a base station in this picture. It's this one. They sometimes hide base stations in a tree because people complain how they look like and they don't like to have them in their nice view. So this is 100% artificial tree, metal, concrete and plastic, and at the top there's a base station. So look around when you go to the forest now. Don't just watch for animals, watch for base stations. Now, let's go to the other side of the part. You obviously have the base station, you have a receiver. What you have to realize is that your mobile phone is a very high, sophisticated computer device that can receive radio signals, okay? And your mobile phone, in fact, has 2 processors. It has the baseband processor and the application processor. So the application processor is usually where your operating system runs on, Symbian, if anyone heard of this. This is where your calendar runs on. This is where all the user interface, all the games run on. And then there's interesting stuff, the baseband processor. This is where the antenna is connected to. This is where the entire secret Nokia stack runs on. In fact, someone from THC 2 years ago managed to make a memory dump of this baseband stack, and I think it's floating somewhere around a BitTorrent. So if you look for it, you can take a look at it yourself. Okay, this is a basic design of a mobile phone. 2 processors, baseband processor, application processor. This is the part we're interested in. This is the secret in there. Let's get to the next one. Okay, let's start with tracing. There are many different methods how you can trace GSM signals. One of the easiest methods is to use a standard Nokia phone. Lucky for us, Nokia sent one of the phones with debug symbols enabled. For 2 years, they shipped a phone with debug symbols enabled, with the whole debug functionality enabled. So what you do is you plug this phone to your computer, use a specialized software which is available on our website, and you put it into a trace mode. And this mobile phone starts giving you all the traffic it receives from everyone. Okay, so it's all the traffic on the beacon channel. Okay. It is a little bit limited. It's not as powerful as a USRP, but we get to the USRP later. But this functionality helped us a lot to see what we try to benchmark it against the USRP. And later on I show you an example trace of how the trace looks like. Okay, let's see the USRP. Okay, this is how the USRP looks like. And maybe you've seen the previous speech, the GNU Radio Software Project. And well, it's just an amazing device. This device can receive anything from 0 to 3 gigahertz. Anything. Doesn't matter where you tune it into, you can receive it. There are people who wrote a GPS receiver with it. There are people who wrote software to receive all kind of television from it. There are people who wrote software to receive all kind of, well, everything you can receive. But no one ever did GSM, because GSM is just horrible complicated specifications, and no one wanted to get into it. You can program it with Python, so it's really easy. It's all open source. The device costs roughly, I think, $800. So you can get one, play around with it. Let's go to the next slide. And yeah, let's go into GSM a little bit. How's GSM designed? GSM works on 4 different frequency bands. This is, sometimes you've heard about this, like a 3-band mobile phone that works in almost everywhere except the countries where you wanted it to work in. Or now there's available the quad-band phone, and that should really work everywhere except where you don't have coverage, but it should really work everywhere. And basically it operates on these frequencies. You have an uplink frequency and a downlink frequency. And the design is very simple. The mobile phone either receives or it sends. It never does the same thing at the same time, which makes our life much easier because we only have to deal with one thing at a time, either receiving or sending. And the great thing is also the receiving part is on one frequency band and the sending part is on a different frequency band. So as long as we stay tuned into one frequency, we are sure on this what we get is all traffic from the base station. Let's take a look at GSM 900. You see that it starts at 890 megahertz and it goes to 915 megahertz. That's 25 megahertz. And each channel is 200 kilohertz wide. That gives us 1,000 channels. Now think about this, 1,000 channels. This means if 1,000 people do a phone call at the same time, GSM is blocked. You can't do it's a DOS, okay? If you have 1,000 phones and you initiate a phone call at the same time, no one else in your area can make a phone call. That's how limited GSM is. Okay? Let's go to the next frequency. Obviously, okay, I have to clarify this. You can be locked into a base station, but you're not assigned a channel. When you're locked in, you're camping on a beacon channel. That's how it calls. You're just listening to the base station. But then when you initiate a call, you're assigned a dedicated channel. And there are only a maximum of 1,000 dedicated channels. So if 1,000 people do a phone call, everyone here in the camp, no one else can do a phone call. Great. Okay. I talked about this already, send or receive. We have the beacon channel. We have the dedicated channel for traffic and SMS. This is something new for some of you. SMSs are encrypted, at least in Britain and Germany. It is optional to the mobile operator if he decides to encrypt SMS or not. Wherever we checked, it was encrypted. Unfortunately, and that made our life very hard, there's something called channel hopping. So every GSM burst lasts for 156.25 bit. Well, if you're a computer scientist and you read 2.2.5 bit, you say, oh my God. But if you're an RF engineer, you say, okay, no problem. And well, we talk about this later, okay? It's actually no problem. But one burst is that long. It's 156 bit, and not all these bits are actual user bits. There are only 52 bits, usable bits in there. The other bits are synchronization bits and tailing and guard bits and whatsoever. One burst only lasts 0.577 milliseconds. And a GSM message is made up of 4 bursts. You need 4 bursts to generate one GSM message. And a GSM message can be a message like, I want to initiate a call, or I want to initiate a cipher, or please tell me where this mobile subscriber is, or please hang up this call, or please hang up my call, or stuff like this. And we talked about this earlier. You have 1,000 channels, and they are divided into time slots. So on one frequency band, this is 200 kilohertz wide, you actually can have 8 dedicated channels. These are 8 time slots. So for the first 156.25 milliseconds, it's time slot 0, and then it's time slot 1, time slot 2, time slot, and so on until time slot 7, then it repeats again. 51 bursts for one multi-frame, and well, that's just some idea how it works. Let's go to the next slide. I'll give you some example of what we actually received with the Nokia phone, okay? This Nokia phone, actually, I bought my Nokia phone on eBay, and funny enough, I paid €1 on eBay. The shipping cost €8, okay? So I paid 8 times for the shipping than for the mobile phone. And I had to buy a special cable, and that cost me €12. So the mobile phones are quite cheap, but the cables are expensive. We've